We're going to talk about angle bisectors and angles. It's very, very similar to what we did with the segments and the midpoint. It's just angles instead of a segment. So just like we had the ruler postulate, now we have the protractor postulate. Just means we can measure stuff and we can subtract. So angle AOB they gave for us was 50 degrees. Measure of angle BOC, notice that they have the M in front of it. It means the measure of angle. So BOC is here. So we went from 50 to 90. So 90 minus 50 is 40 degrees. You could look at the bigger numbers as well. It's 130 minus 90, which is still 40. AOC, 0 to 90, so 90 degree angle, that's our right angle. EOD, 0 to 30, 30 degrees. BOD, so here to here, so we have 130 minus 30, or 150 minus 50, either way, we get 100 degrees. An angle BOE, again, we've lined up if we're looking at the top set of numbers, so it's 130 degrees. Again, how to use a protractor, we can use geometer, not that big a deal. So if we wanted to measure this and we actually had our protractor or our geometer out, we could see that measure of angle TQP is 115 degrees, measure of angle TQR is 24 degrees, and RQP is 139 degrees. So again, just like what we did the other day, using results, describe any patterns. When you add measures of two smaller angles, you get a measure of a larger angle. And that is our angle addition postulate. Just like we had the segment addition postulate, we can do the same thing for angles, as long as they don't overlap. So when we dealt with segments, we had to make sure that the point was between the 2 points. Now we're given that a point is in the interior of an angle. So what that means is, we have angle ABC, angle D is in the interior, so that we can get our other angles. So determine the measure of angle ABC without measuring if you're given the measures of angle ABD, this guy, and DBC, this one. So the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. That's just our angle addition postulate. Again, I suggest draw things out. That way we don't get confused, we don't get mixed up. So Y is our angle, P is in the interior, and then we label XYP is 25 degrees, PYZ is 50, so what is measure of XYZ? Well, you just add them up, 75 degrees. Do the same thing for letter B here, and you can draw your angles however you want, but we have RTD, M is in the interior, so RTM is 40, and RTD, this whole thing is 65. So we're actually using subtraction, and we figure out it's 25 degrees. So again, just like we did with segments, now we have something to solve for. We have angle E interior, EFH is 75 degrees, HFG is 10x, and the whole thing is 20x minus 5. So we set up an equation, 10x minus 5 equals 20x minus 5. Subtract 10x from both sides and add 5 to both sides. Divide by 10, x equals 8. X equals 8, and if I wanted HFG, I got to plug that back in to this quantity. 10 times 8, 8 degrees. Similar to what we did before. Lines DB and EC intersect at point F. If the measure of angle BFC is 44, and AFB is 61. Then AFC, well, you add those two up, 105 degrees. AFE, well, we know that these three together give us 180 degrees, it gives us a straight angle. So 180 minus both of those will give us the measure of angle AFE. 180 minus 61 minus 44 will give us our grand total of 75 degrees. And we can do the same thing for EFD. 180 minus 75 minus 61 will give us this remaining angle. So we get 44 degrees. The bisectored angle is just like our midpoint of a segment. It cuts it in half equally. We have some things over here. If we want to talk about the measurement being equal, we use the M. If we're talking about just them being congruent, we use that symbol. I think things that you've seen before. So these are both 30, or if they're bisected, they're both 30, they're both the same, whatever that is. So given AH, ray AH bisects MAT, again, I would draw that out. So H bisects AH, so it has to be in the interior. If MAT is 70, while MAH is half of that, it's going to be 35. If we're going the other way, if half of it is 8 or half of it's 80, MAT, the whole thing would be double, 160 degrees. And we'll look through this last example. The QP bisects, and again, I suggest you draw it out, DQL, QP bisects at ray QP, and DQP is 5x minus 7. PQL is 11 plus 2x. Determine the measure of DQL. Well, we know these are congruent because they're bisected, so they're equal to each other. Then we use our substitution property to plug in the values that we have. We're going to use subtraction property of equality, subtract 2x from both sides. Addition property of equality, add 7 to both sides. And division property of equality, divide by 3. So we get x equals 6. Now that's not what the question is asking. We want to determine what measure of DQL is. So we have to substitute that 6 back in to DQP or PQL. Actually, if they do both, we get they're both 23, which of course they are. And then 23 plus 23 is 46. Or we can just multiply it by 2 because it's doubled.